Hi all, welcome to my channel. Today we will discuss about the important terminologies. So we are going to discuss about the important terminologies in neural networks. So the first important terminology is weights. So we are going to discuss about the weights. So what does it mean by weight? An artificial neural network is made up of nodes or neurons that are organized into layers. These layers are connected to each other via weights. So what does it mean by weight? Weight nothing but here what is going to be happen? Artificial network is made up of nodes or neurons that are organized into layers, and these layers are connected to each other via weights. So you see here the diagram for weights. Now in this it represents the input values, this represents the output values, and it represents the hidden. So here weight nothing but the value between input as well as a hidden. So these are called as weights. Now you see here this is a weight, and you can also see this is also weight, this is also weight, this is also weight. So remember here one of the important point, weights are nothing but here whatever the layers are connected, that is connected to each other via weights. So here in between input and hidden layer the connected value is weight. Okay, so this is called as what we have weights. So now you can see here each weight represents the connection. Each weight represents the connection between two nodes. When the network receives an input at a given node, the input is passed to the nodes in the next layer via connections, and input will be multiplied by the weights values assigned to those connections. So important thing is each input represents each weight represents the strength of connection between two nodes. Now you see here 0.35. So here this is called as a weight. It represents the strength of connection between two nodes. When the network receives input at a given node, the input is passed to the nodes in the next layer via connections, and input will be multiplied with the weights. Important point is we are going to multiply input value with the weights. You can observe here the diagram which will represents the weights. Here this is a diagram. Here 160 and 55 are called as input values, and 0.2, 0.8 are called as output values. In this, hidden layer values are 67, 38 and 121.9. Now we are going to talking about here in this diagram weights. The weights are 0.35, 0.2, minus 0.1, minus 0.4 as well as a 0.18. Remember, we are going to multiply input values with weight. In this input values are 160 and 55. 160 is multiplied with 0.35, 160 is multiplied with minus 0.1, 160 is multiplied with 0.7, 55 is multiplied with 0.18. Now you see here what is going to be happen. 160 is multiplied with 0.35 plus, now we are going to find the value of here 55 into 0.2. So here we are going to find the value of this one. If you see here, it is connected with two values. This line is 160, this line is 55. That's why we have 160 into 0.35, 55 into 0.2, 160 into 0.35, 55 into 0.2. So the final value is 67. We need to add these two values. If you see here, it contains again two values. One is 160 and second one is 55. 160 into minus 38. So here minus 60 into minus 0.1. 55 into 0.4. This is a minus 0. Minus 38. So here 160 again we will connect with here 160 into 0.7, 55 into 0.18. So this final value is 121.9. So this is all about the weights. So here 0.35, 0.2 minus 0.1 minus 0.4, 0.18 are called as a weights. So remember the first important terminology is we have, this is nothing but a weights. So now we are going to talking about the second important terminology we have on the screen. Now you see here the important terminology here we have, that is the bias. Very important terminology. This is the bias. So what is mean by bias? First of all, remember bias is represented by using B. Bias provide a critical additional layer of flexibility to neural networks. Biases are essentially constants associated with each neuron. Remember, biases are essentially, it is a constants. These are a constants associated with each neuron. So unlike weights, bias are not connected to specific inputs but are added to neurons output. So remember, in the previous we talked about the weights. Weights are multiplied with inputs. Weights are connected with or added with the inputs. But if you see here, what is going to be happen? These are going to add with the outputs. So now you see bias is used to shift the activation function to the left or right, which helps the neural network learn the best output values. So bias is used to shift activation function left or right. Now you can see it is a diagram for bias, how represents the bias. Now you see this is a diagram. So here x1, x2, xn are called as input values. W1, W2, Wn called as weights, B is called as bias, F is called as activation function, Y is the output. So the mathematical representation is Y is equal to Wi xi plus B. So W1, W2, Wn, this is called as Wi, x1, x2, so on up to xn. So Wi xi plus we are going to add bias here. So in order to get output, we are going to multiply w1 x1, w2 x2, so on up to wn xn plus b. Now let us see one problem here. We are going to have x1 is equal to 0.5, x2 is equal to 0.8, w1 is equal to 0.3, W2 is equal to 0.7, and let us assume bias value is minus 0.1. So the weighted sum is, formula is y is equal to w1x1 plus w2x2, so on up to wnxn plus b. So we are going to substitute these values here. W1 is equal to 0.3, x is equal to 0.5, w2 is equal to 0.7, x2 is equal to 0.8. So substitute all the values, then you get here 0.31. So this is all about the bias. Now let me explain about the threshold value. Very important term we have here. So what is meant by threshold? Remember, threshold is represented by using this symbol. It is a specific value that influences the activation of neuron. So threshold value influences the activation of neuron. It determines the neuron decision boundary. So it determines the neuron's decision boundary. So you see here x1 is equal to 0.5, x2 is equal to 0.8. Let us assume w1 is equal to 0.3, w2 is equal to 0.7. Threshold value is 0.6. So here what is going to be happen? We are going to find out the weighted sum. Z is equal to w1 x1 plus w2 x2. So z value is 0.7 after substitution. Now what is going to be happen? We are going to compare this activation Z to threshold value, then when you get this comparison Z is greater than threshold, the real value is 1. So when you compare this value, Z is greater than threshold value, then value is 1. When you compare Z with threshold value is less than, then it is going to have 0. So this is called as a threshold. So threshold nothing but it determines the neuron decision boundary. Okay. So finally, we are going to talking about the what we have, learning rate. So learning rate nothing but here it is used to control the amount of weight adjustment at each step of training. It is represented by using alpha, and the learning rate ranges from 0 to 1. So in between 0 to 1 we can have learning rate. So it determines the rate of learning at each time step. Remember, so it determines the rate of learning. So we are represented by using alpha, and always the learning rate must be ranges from 0 to 1. So this is all about the important terminologies in neural networks. So thank you for watching this video. If at all you have any doubts, you can ask me in the comment section. Thank you.